get the required application acceleration. So, but we should not forget something about PCIe. So PCIe is an important interconnect which has been enabling the computer architectures worldwide to get the required acceleration. And what NEC has done here is we have extended the PCIe switch over Ethernet. And with this, we have kind of opened a new way of looking at connecting various PCIe devices remotely to our CPU. And with the IBM Power 9 PCIe Gen 4 support, so there are other interfaces as well, like NVLink and BlueLink. So PCIe interface seems to be a little untapped, and we'll be looking into that how we can extend that and leverage a huge variety of applications. So the PCIe or Ethernet or distributed I/O system. So this we'll look into two aspects, which is one is the ubiquitous computing, so computing from anywhere, and second is the IoT solutions. So that's what the remote capability allows you to do. Now, if we look at the real-time data analytics challenges that we have such accelerators like GPUs, FPGAs, Xeon Phi. Xeon Phi is out now. So we'll be introducing vector engines as well. So these accelerators allows real-time data analytics, but the real problem is having an interconnect to connect all the architecture together and get the value out of it. And with Express Ether, we are kind of introducing a system on network kind of principle, with which we can interconnect all these computing elements as well as the sensor elements together to the CPU without the involvement of any new software stack. With that, I would like to introduce Express Ether, so which is a PCI extension over Ethernet. In this technology, what we do is we extend, we basically take out the PCIe slots out of the chassis of the computer, and we extend it over Ethernet, and making sure that we do not have any performance lag. And this, the Ethernet allows us to give basically two capabilities. One is the distance capability, so you can extend it over to 2 kilometers or more. And another part it introduces is the switching capability. So you can switch between hardwares. So we'll be looking at it from the different aspects that how we were able to achieve such a configuration. So what I'm saying is that we were able to put a GPU or an SSD or an accelerator remotely as well as locally, and we were able to achieve the same performance. And that means the Ethernet behind is literally invisible. So what is Express Ether? It is just an extension of the standard PCIe stack. So what you see on the left is a CPU with a PCIe switch, and the upstream and the downstream ports are basically divided by the Ethernet switch in between, or the Ethernet interconnect. And all the I/O devices can be connected seamlessly as local. So any I/O device which is connected through Express Ether, or any I/O devices which is connected to a standard PCIe switch will be seen as same local devices to the CPU. And this Ethernet fabric is hidden. So how it is hidden, I will be getting into the details of that in my next slides. So how we can see it? We can see it as the whole system now as a broad scale single computer. So that means with this enablement of Ethernet switch and the distance capability, we can have CPU connected to your GPUs or other PCIe devices remotely, and the CPU will see them as local slots, and we can extend. So for example, if you have a GPU cluster or a SSD cluster which is noisy and which you don't want by your side, by your desktop, it can be located into some other room, and you can get the same performance as local. So you can have a linear system at your desk side, and you can have a huge system probably in your server room. So and the whole part of achieving the performance is that the entire protocol is implemented in hardware. So so we have a HBA switch. So how it is implemented is within the server we have a Express Ether NIC card, which is a dedicated NIC card for this protocol, and it has two optical fiber cables, which is a standard Ethernet cable, and we have a standard L2 switch. And then it is connected to that IO box, which you see on the right. And within this IO box, we have multiple slots on which you can actually install your card. So basically, it's a bare metal interconnect, which we are demonstrating here. So going on to the software stack. So on the right, you see the standard Ethernet stack. On the left, you see the standard Express Ether stack. So we do not introduce any software protocols to manage the PCIe packets. We deal with everything in hardware. So everything in hardware leads to the latency under 2 microseconds between the, and with the dual Ethernet capability, we actually have the capability to get the same performance. I'll be discussing that further as well. So briefly talking about the various features of this resource disaggregation platform is that we have the equivalent direct connection to CPU, like I already told. We have a low latency because we deal at the L2 layer of the switch. So we don't go to the higher L3, L4 layers. We are directly, so you see here is the Ethernet frame. So within the Ethernet frame, we have the Express Ether packet, which has the TLP PCIe packet. And this is all encapsulated at the hardware layer and provided to the IO device and accordingly to the CPU, vice versa. And so since PCIe is a lossless protocol and Ethernet is a lossy protocol, so what we have done is within the hardware we have implemented such methods that allow lossless communication between the CPU and the host. And also the switching capability with the Ethernet switch allows us to dynamically reconfigure. So that means I can basically, for example, if you have a GPU, I can reallocate the GPU from one user to the other dynamically with a hot swapping capability without shutting down the system. So, and for this dynamic switching capability, we do have a software stack with REST API interfaces, and that you can integrate in your standard network softwares for the IT. And another part is the dual path. So what we do is we have a dual connection between the Express Ether host side and the IO side. And the dual connection allows us, so each connection is 40 Gbps. So dual connection means 40 plus 40, it's total of 80 Gbps of bandwidth, and the Express Ether interface which we are providing here is PCIe Gen 3 X8, which is 64 Gbps. So we are basically running 64 Gbps over an 80 Gbps network. So whatever protocol overhead is there, it is compensated within that extra 20 Gbps. So and also this dual path provides us reliability. So suppose we have a Ethernet network and we have multiple paths from host to the IO. So we make sure that our packets are delivered in a lossless fashion with this kind of protocol, because we cannot afford to lose packets in case of PCIe. And another part, in order to maintain the performance, we have the frame rate control. This is different from the TCP/IP RNO. So normally TCP/IP RNO is a lossy approach, and as soon as the network hits the congestion boundary, there is a packet loss. But instead, in Express Ether, we have something called as a probing frames management on the management layer, which continuously sends probes after a definitive interval of time and make sure that the entire bandwidth is fully utilized. This is very important in case of highly computing devices as well as fast storage devices which continuously require full bandwidth. So if we are making sure that we achieve the same performance as local using this frame rate control in our protocol. And what are the possibilities with this? We can have such possibilities that we can have, from the storage side, we can have such JBots, which can be on the fly can switch over or fail over between, if there is a failover, it can switch over between the drives with minimum latency. I have a use case today to discuss with that, because we have another software, the Express Cluster X. Integrated with Express Ether, we can actually have a quick failover recovery mechanisms, which is of the order of 5 nines. And this is how it looks like for us, for Express Ether. So if you see, there are 4 hosts and there are multiple IOs. So the logical view would be something like this, that we have multiple hosts allocated to multiple groups of IOs. With the Express Ether Manager software, we can reallocate these IOs to different hosts on the fly. And this dynamic reconfigurability is possible only due to the Ethernet fabric involved in between. And this basically allows us to even manage such a network as well, because the management server has a management layer or a protocol which is besides the data communication. And in this we can do the configuration or the grouping of the IOs to different hosts, as well as the monitoring of the traffic which is happening on the network. And for this, we already provide the REST API interface for the Express Ether Manager. And through this, you can actually monitor the entire network and how it is behaving. Now, looking into that, once we see once I say system on network, that means it's the communication is not only between host and IO, it is between IO and IO as well as host and host. And also, we can have one IO allocated to multiple hosts as well. So we are trying to enable, so we support all the 4 configuration, which allows the interconnect to talk among each hosts as well as IOs independently. So that means these IOs can talk among themselves without the involvement of the host, just by through the Ethernet switch. Also, if the hosts want to talk among themselves, they can also connect through the Express Ether protocol. And this basically allows us a variety of applications, and there are 2 major areas we have divided our applications in. So on the top you see the 1G 10G version. The 1G 10G version is basically meant for IoT purpose, where you can connect your various PCIe based sensors directly to your CPU. And we are not challenging the IoT stack already, which has implemented the entire software stack, but what we are providing here is bare metal connection to the CPU directly up to the sensors. And you can build up your own software stack or your own system. That means if you have a camera located remotely, it can directly talk to your CPU without any software stack. And that's minimum latency, and this provides huge advantage. For example, if not only IoT sensors, but if you want to implement something like your thin clients, like DVI connections, you can actually build up a system using Express Ether 1G and 10G versions. The below one is more of the computational intensive version, which is the 40G version. So the 40G version is basically meant for connecting your computational and data intensive, memory intensive IOs, for example GPU, GPUs, vector engines, as well as FPG accelerators and SSDs. Now this is more from the computation side, and if you see, if you can imagine, we have a Power 9 system which has IoT sensors connected to it, as well as the computational elements connected to it, forming a kind of a whole system on network kind of topology. And since all of them can talk among themselves independently over PCIe, this actually forms a perfect resource disaggregated system. And we have some examples as well, which we did in Osaka University, where we were able to realize such a system. So before moving to that, I would like to share some performance data as well. So this is the performance data of PCIe SSDs, remote versus local, and the efficiency which we have achieved is 100% to 97%. And we were able to achieve this efficiency in random as well as sequential reads and writes, and we have GPU P100 also, in which we have achieved remote versus local as same for the in-body test. So there is, and even in terms of IOPS, so previous one was for the bandwidth. This is in terms of IOPS, we were able to achieve the same as local. So as I was mentioning earlier, so you can imagine such a system in which on the left bottom side you see the sensors and the remote IO devices connected with the 1G, 10G version. And on the right you see the 40G versions through which you can connect your GPUs, accelerator FPGA, even vector engines, which is NEC's another product, and even SSDs. So you can imagine that you can have an entire system on network with these two protocols mixed together. And we did the same actually in Osaka University, where we had 64 servers and 70 IO devices. And we were able to dynamically allocate the servers to the GPUs as well as to the SSD on the fly. And they were also able to realize such a VDI application as well, in which they were able to have a split display. And these are these all are extensions over using Express Ether. And then we have some other applications like PCIe extension interfaces. So we can have such thin client-based solutions, as well as in medical sector, if where the sensors are not accessible to the doctors, they can be remotely connected directly to the PCIe to the CPU to the Express Ether. So this is an example, another use case of the failovers. Now we were looking at extending the computing and the IoT sensors. With this slide, I want to explain you that we can also achieve failover mechanisms as well. So SSD failovers, we were able to achieve fast failovers within a couple of microseconds from a primary server to the secondary server using Express Ether. That means within the PCIe slots, there are two SSDs. One fails, it automatically switches over to the other without any, again, software stack. And this makes things a lot simpler at the application layer, at the OS layer, because the OS as well as the application is oblivious. It sees it as these are active slots which are available. So if we extend this thing, then we are able to apply Express Ether in what we call as a 5-layer model at NEC. So in which L1 layer is the device computing layer. So we can apply Express Ether for the IoTs here, as well as for the edge side. And the cloud computing layer, we can have the 40G, the fast version of the Express Ether. And soon enough, in our coming years, so we have already, in the PCI SIG, we have already demonstrated the software and the Wi-Fi version of Express Ether. That means we will be able to achieve the same performance as local using Wi-Fi, and not just Ethernet. So, looking at that, we envision that PCIe or extension over Ethernet or Express Ether, we can have everything interconnected. And with the 5G coming in, with more connectivity available, because there will be less and less downtimes, we can make sure that such protocols can leverage such platforms and implement this combination of standard revolutionary to time-tested protocols, which is PCIe and Ethernet together, to achieve a very simple interconnect stack. And on that, so what we can do is from my phone, I can actually run a program on a compute node and get the output back, and basically feed back it to the sensors, or we can get a sensors output and get it automatically computed over the computation stack and get the active output. So that means we can actually have a real-time data analytics system using PCIe or PCIe switch extension over Ethernet. Yeah. So summing it up, we can actually, Express Ether allows us to give distance capability and dynamic switching. It has the same performance as local versus remote. Moving within the chassis devices, plug and play. So we support hot plug, so you can plug out your SSD and plug in on the fly without shutting down the system. And most of that is the best use case. I think there are a lot of PCIe devices in the world right now, and it will take some time for people to move on to the better protocols like NVLink and BlueLink. So I think supporting PCIe is a very good move by the IBM Power Systems, still supporting them, and we would like them to also leverage that support by using legacy PCIe cards. And with Express Ether, you can definitely take it to the next level. So definitely this kind of resource disaggregation using Express Ether is the novel way or a simple way forward to actually achieving the best performance and yet not introducing complex protocols. So the approach is quite different from what NVMe over fabrics or other Rocky support, because we already these all supports which are getting into a specific kind of protocols are all derived from PCIe standards. So if we can replicate, if we can simply extend that standard over Ethernet, that would be a simple thing to do. So, and we have a consortium as well if you want to join. And we are IBM OpenPOWER ready, and this system has been tested over Power 8 and Power 9 systems. And we look forward for you guys to actually introduce some good applications, and we can explore more. So that's all from my side. And if you have any questions, please let me know.